In this session, we want to give you some back-end information about how cells operate. And in this operation, we need to understand some things, because look, in the next video, we are going to do something called equality of cells. So we need to actually understand at this level how cells work in the back end. So generally, we have a number raised to the square root of a. The square root of a is um, a way of getting back the root of the number a that was squared, as we explained in the first video. And what is this actually doing? We say square root of a can be written like this. We also have square root of a cubic root. This is for cubic root. So we put the number here. Here, naturally, we are supposed to put 2 here, but we don't actually put it there. And then there is another one, fourth root of a. We have fifth root of a, or we can have n roots of a. So basically, look at this. When we are having a number, let's say 2 squared, if you square 2, you are going to get 4. So if you want to go back, we said you have to use square root, but what is square root actually doing? If you have a number, let's say 2 itself, any number that you are seeing simply like that, there's a power component of it, and that power is usually 1. 2 to the power 1 is the same as 2. So the non-counting number that we have, like 0, 1, 2, 3, 4, actually they have a power of 1, 1, 1, 1. But we don't actually see that, right? We don't actually write it, because any number raised to the power is the number itself. So we just ignore that. So if you are squaring this number, meaning you are going to touch the power, right? So if you have 2, you want to square the power. What we are actually doing now, we have to do that one that is originally coming with the number times 2. So if you do that, the indices, the top become 1 times 2, which is 2. So be 2 squared. So 2 squared, which will give us 4. That's what we actually have. 2 squared is equal to 4. Now we want to go back to we want to go back to having the root, and to having the root meaning that we want to have 2 to the power 1. How can we manipulate the power so that it will be 2 to the power 1 again? So what happened is that when we were going from 2 to the power 1 squared to 4, what we do to the power is that to 1 is that we multiplied it by 2. But if we want to go by, what do we have to do? We just have to do the opposite of multiplication. So instead of multiplying that power by 2, we now divide it by 2. Right? That's how to find the square root. So if you want to go back on a number 4, so 4, so you want to go back to 2, you have to divide this 4 by half in order to get 2. That's what happened. But because if you want to go to 4, we just have to 1 times 2, which is 2 to the power 2, which is 4. So but if you want to go back, instead of doing multiplication, you now do division. So this power, this fractional power that we have, this power as a fraction, we don't want to write the fraction. So what we have, so that's when the symbol square root replaces the 4, the fraction. So square root of 4 is the same as 4 to the power half, and then which is equal to 2. Basically, we don't want to write the indices to be powers. So another simpler or nice way of writing the powers to be when they are in fraction form is just be writing them in the form of square root, using square roots. So if you this one that we are having, the square root of a that you are having at initially, as we say that if it is square root, we don't actually write the power or the number in between, because this square root thing starts from 2 going. So square root of a is actually a to the power half, and then square root of a cubic root of a is actually a to the power 1 over third, and a here is 1 over 4. This a to the power 1 over 5, a to the power 1 over n, based on what n is. So this is how square roots happen. So square roots are just replacing, instead of having the powers of the numbers being a fraction, they just want to use this symbol in order to replace that. So if you have 3, if you don't have anything here, it just means that you are finding the square root. If you are having 3 here, mean you have cubic root, fourth root. So we don't want to have the indices powers to be fraction, so we just change them into using the symbol square root symbol. That's what square root actually does behind the scene. So it's just a fraction power that we want to just switch and represent them nicely. Now, why is this important? Why are we learning this? And why are we talking about this at this level? We have something like square root of 2 to the power 2, all this to the power 2. So what is happening is that the thing in the bracket, we say it can be also be written as 2 to the power half because of the square root, right? But then this 2 is already here. This 2 is the same one here, and this square root sign, that's what we are putting here as the power half. That's all we are doing, because we say that this is actually a fraction, and when it's like this, simply that it's just 1/4. So what happens is we have to use the power of indices, right? So for indices, when something is multiplying like this, you have a to the power n times b, it is equal to a n times b. That's what we have using revising your indices. So what do we have here? This one's supposed to give us to the power half times 2, following this rule of indices that we are using. So if you do that, 2 to the power, so the powers at the top here, this you can put this in your calculator. 2 times 2 will give us 1, which is just equal to 2. At the end of the day, square root of a all to the power 2 is just simply going to give us a. It's going to give you an a, because this 2 is going to simplify this 2. So what happens is that if because this is a square root and we are squaring it, it's simple to just nullify the powers by that. This is very important in what we are going to be doing next. So basically what I just said right now is that when you have a power, when you have a square root, and square root, especially since we are doing square, we are going to limit ourselves to square root. If you are finding square root of a number, and then you realize that there is a particular power 2 at the top, is they say it's just a, because these two will just remove this bracket. Sorry, not the bracket, the square root sign. That's what it does. So assuming we're having a cubic root of a to the power 2, we are going to just simply have to the power 3, sorry, because it is 3 and we are doing cubic root and we are all power 3. This 3 can easily do that, but square root cannot do that for this. Square root cannot eliminate that. So what I said earlier, you cannot say that these two eliminate this square root sign. Why? Because this is a cubic root sign. So a power 2 cannot eliminate a cubic root sign. But if you have, as we said, if you have just a square root like this 2, it just means that 2 is here, but we don't write it for 2. So these 2 just eliminate this guy. Yeah, that's how to do the elimination when something is raised to a power 2, power 3, based on the type of roots that you are using. Now, this is the most important thing, what we actually want to touch on in this session, is you to understand that if you have an expression in a bracket, a minus b all to the power 2, and you have another expression, let's say this expression, a minus root b all to the power 2, these are not the same. So you see that in this case, I will say this will eliminate this. I will tell you why. It's just going to get a minus b, but this one is not going to be in that the same as that. This one is just trying to telling you to repeat them and expand. So you are repeating this twice, and then you do expansion. You expand to have a squared plus b squared minus 2 root ab. So if you do the expansion, you finally get this. So doing the expansion, we do this in the multiplication video. Kindly go back and watch that video. But right now we are trying to look at when and how to eliminate the square root sign. So you see all these things are raised to the power 2. All of them are raised to the power 2 in the bracket. And inside the bracket is covering every term inside the bracket. Sorry, the square root sign. The square root sign is covering every item inside the bracket. So the square root is here, and every item inside it is inside that umbrella of the square root. So for that, the power 2 that was here was able to eliminate this simply. But in the cases where we are on this one, we are having the square root of a minus square root of b. We are seeing that all of them, right, under the square root, all of them are not under one umbrella. So it's impossible to just say that these two eliminate this and this. It doesn't happen. Everything inside the bracket must be under one square root umbrella before that thing can be eliminated. If it's not like that, then you have to expand yourself. So this one needs expansion. Even if you have square root of a minus 3 all to the power 2, you will see that this square root of a is one thing and negative 3 is also one thing. It happens that everything is not under the square root, so this one cannot eliminate it. It's not going to happen. It's impossible. So it doesn't happen like that. So you have to do expansion for this one. So you need to expand this particular one. But if you have the same thing, if you're having the same thing and all of them under one umbrella, that's square root of a minus 3, all of them are under the square root umbrella before all of them were squared in a bracket. Then because all of everything inside the bracket is under one umbrella before it is squared, then these two can eliminate these two simply. Then we are going to have a minus 3 like that. That's how you need to be careful. So eliminating the square root does not apply for items where or everything is squared. The entire bracket is squared, all right, but some of the items are left out or outside of the square root sign, or the square root sign are occurring multiple times. So there's no major umbrella of the square root that is covering everything. If there's nothing like that, then you can't use the elimination. Then you have to expand. But if there's something like that, then quickly the 2 and the square root can easily go away. So simply put, we can have square root of a minus 1, this one to the power 2, this one cannot eliminate this, so you have to do expansion for this. But if you have square root of a minus 1 and everything is under the umbrella, then because every item inside the bracket is under the umbrella of the square root, then this eliminates this. Yeah, this is what we are going to use in the next video. And if this eliminates this, you are going to suggest that a minus 1 as your final answer. Yeah, we are going to use this knowledge in the next video where we'll be talking about the quality of sets. That's why it's very important for us to take our time, pause here, and then try to understand how these things are expanded. These things are done so that we don't confuse it when we are doing the expansion and trying to find a quality of sets. Right now, we have learned the division, multiplication, sets, and introduction, and all the things when we use this information at the back end info to also help us to now we are ready to start solving a lot of questions, and then the various manipulations, so that we see how we can find our way around solving set questions. Thank you very much, and see you in the next video.